Okay guys, so the first thing, obviously, before we start our new unit is we need some vocabulary. So the first thing that we're going to talk about, obviously, is what's the definition of a statistic? A statistic is a number calculated from data. So obviously, like you take a survey and then you're trying to worry about the results of the survey. You run a statistic. Now, there's different types of statistics in terms of what they discover. Stats of measure are old school. So we've done mean, median, mode. So remember, the mean is the average. So that's where you add up all the numbers, divide by how many you have. The median is the middle number of the data, once you list them from least to greatest. And the mode is the data that occurs the most often. Now, so those are older. We're not going to really focus too much of those, but just to give you an idea, they measure the overall data, like the center of it, what's related with that. What we're going to focus on more today are the statistics that measure the spread. So older for the range is high minus low. So you take the highest number and you minus the lowest number, and that tells you how spread the data is, the range. But even more so, what we're going to focus on today is what's called the standard deviation. How far data is spread out from your mean. And this little notation kind of looks like a weird R almost. That is the notation for standard deviation. That's the symbol, I suppose you could say. And then, now we're not going to do it as much for this class, but anybody going to stat analysis or AP stat eventually, when you get data, let's say I give you data for a survey, this is how you would put it in the calculator, and the calculator will actually find all these numbers for you. But we're not really going to do that for here, but just for future references. So, let's take a look here, and we're going to talk about these bell curves today. The bell curves, there's 3 different types, okay, and we're going to talk about how they're spread out. So these vocabularies are big. The 3 main descriptions are skewed to the left, where you have less data on the left, kind of like the tail end, and it kind of goes upward, and more of the data seems to be towards trending on the right side of the graph. We have what's called skewed right distribution, which is again kind of like skewed left, except lesser on the right side. And then this is the main one we're going to focus with today for now, is symmetric distribution, which is where it's approximately even on the left and the right. And when you have that, you can actually draw yourself a little line here. This means the mean is approximately in the center of the bell curve. And we also call it a bell curve. So it's in the middle, and that's going to play a big role as we create these models today. So our goal is to create these models. Now, so again, like the box here at the bottom says, when the data is symmetric, centered around the middle value, which is the mean, no skewed left or right, we call it normal distribution. So you're going to hear me say a lot, normal distribution model. Or, depending if you Google the stuff, it might say normal bell curve. But for the most part, they use normal distribution model. Examples of real-life data. So a lot of times, like I said, they take data from surveys. They take data from real-life events. So some of the most popular ones that go around a normal distribution are batting averages. So you always have an average amount, and then you have the really good players, and you have the really low players. IQ scores, average IQ versus the really high IQ and the low, heights, body temperature, and these are just some of them. There's a lot out there. So we're going to focus today on creating normal distribution models, all right? So we're not going to complete this whole packet, but this is basically what we're going to be doing, normal distribution model. So let's turn the page, okay? And let's look at a normal model. Okay, so, and we're talking about normal model, guys. Again, we're talking about symmetric. So think evenly split from the left and the right. So, in order to create a normal model, you need to have your mean. So right here in the middle, of every normal model is your mean. Then from your mean, what creates, okay, the spread of the data is your standard deviation. Now, there is a formula for standard deviation, but in this class, you don't have to worry about it. If you're going to go to AP Statistics or Stat Analysis, you will actually learn the actual formula to derive the standard deviation. This is a specific number that data gives you, but we're not going to do that. I'm always going to give you the standard deviation, or you're going to use the normal model to find it. You won't have to use the actual formula. Now, every normal distribution model, every symmetric bell curve always follows what's called an empirical rule. Now, this empirical rule is also called the 68, 95, 99.7% rule. So this, guys, means it breaks down the data within standard deviations. So within the first standard deviation, so the first spread away from the mean, 68% of the people or survey or data lies in that. Versus 2 standard deviations away from the mean, so 2 values of numbers, 95% of the data lies in. 3 standard deviations away, 99.7% lie in. Now, our goal today is to apply this rule and create 2 normal models, and from there, analyze it using this empirical rule. So let's take a look at example number 1. So like I said, one of the popular normal distribution models deals with IQs. So our first goal is to draw the normal distribution model. So let's draw it. First thing you must do is draw your number line, and you always put your mean in the middle. So, since it says here, the scores of an IQ test are normally distributed, that's how I know I'm drawing this model, around a mean of 100. So then this mean will go right here in the middle. Standard deviation is 15. Now what that means is, guys, that they've already calculated from this piece of data. So let's say they did a survey of 1,000 people. They found the average of those people to have an IQ of 100, and then they ran this formula, okay, again, we're not going to do the formula, but they found this standard deviation of 15, which means that from the mean, we add 15 to the right, and we subtract 15 from that. So 115 and 85. This is 1 standard deviation away from the mean, which means, according to our empirical rule, that 68% of people, based on these results, would have an IQ between 85 and 115, because that is 1 standard deviation away from the average. You keep going out and you do 3 standard deviations. So again, I'm going to add 15 here, and I'm going to subtract 15 here. 2 standard deviations away tells us that 95% of people will have IQ scores between 70 and 130. And then the 3rd standard deviation away would be 55 and 145. So this says at the 3rd standard deviation, basically everybody, 99.7% of people, are within those IQ scores. So we can draw kind of like a little bell to go over it. Now normally, guys, if you were to describe the bell in further detail, it's because you'd have the actual data values. We don't here, we only have the mean and the standard deviation, so this is how you create it. Now, we're going to use our model to determine a percentage of IQ scores that are within certain values. So let's see. If I want to know what percent of people are greater than 100 IQ, well, since 100 in a normal model is always, since this is the mean, I guess you could say, the mean is in the middle, then if it's greater than that and it's a symmetric model, normally distributed, it's half the amount. So it's 50%, assumingly based on these stats, that 50% are going to have an IQ that's greater than 100. Okay. Looking here, between 70 and 130. So now, okay, let's find 70. 70 is right here, and 130 is right here. The first thing you want to do is ask yourself, which standard deviation is it? So when we started from the mean, the first standard deviation were these two numbers. The second standard deviation are 70 and 130. And according to our empirical rule, between 70 and 130, 95% of our population exists. So according to that. So then that means 95% of people will have IQ scores between 70 and 130. Okay, sometimes it gets a little trickier. Okay, so greater than 145. 145, so is right here. This is the third standard deviation, the upper side. So we're talking about the really, really smart people. Now, I want to know what's even bigger than that, right? So that's on the outside of the standard deviation. It is not on the inside. So if this is the third standard deviation, inside the third standard deviation is 99.7. Okay, so again, inside, between 55 and 145, inside is the third standard deviation. Then what's outside? Well, remember, this model is based off 100%. So if inside is 99.7, I can do 100 minus 99.7 and get 0.3. But there are two parts that are outside. You have these very low IQ, probably barely functioning people, and you have this super extreme IQ. Between these two, it's supposed to evenly split this number. So when you cut 0.3 in half, that means it is 0.15 above and 0.15 below. Because remember, you want it to add to 100%. So 0.15, 99.7, and 0.15 would add to 100%. So to be bigger, that's the really smart pants. And then to be lower would have to be the same because they're outside the third standard deviation. Evenly split the third standard deviation. Okay, that's the idea. So it gets a little bit of math. You can use a calculator. Below 85 here. So if we're talking about below 85, here's 85. 85 is in the first standard deviation. So same concept. Within the first standard deviation, between 85 and 115, is 68% of the data. I want to know what is outside of it, and only outside on the left, not within. So again, it's out of 100%. So I'm going to do 100 minus 68, which is 32. So that means, okay, if inside my hands here is 68%, outside where my hands are covering is 32% rest of the data. Well, what that means is it has to be evenly split on the left and evenly split on the right because it's a symmetrical model. It's normal distributed. So 32 divided by 2 must be 16. So this, when you divide it by 2, this has to be 16%. 16% less than 85, 16% here. Now it can get a little trickier, like even the 115 and 130. That is just this region. I want to know what percentage of people have an IQ just between these two. Now both of them are on a standard deviation. This one is the first standard deviation, this one is the second. So that can help us. How does it help us? Well, look here. The first standard deviation is 68%, from 85 to 115. Well, guys, you can split it up because it's a normal model. You could split 68 into 34% and 34% if you'd like. You could split that up. So then from here to here is 34%. Now, obviously that hasn't answered the question. Then look at the second standard deviation. The second standard deviation is 95, okay? You can split up 95. 95 divided by 2, which means it would be from here, the middle, to here, to here. 95 divided by 2 is 47.5% on both sides. If you were to cut the 95, the second standard deviation, down the middle, that's basically what you're looking at. So think, guys, if I'm trying to find this shaded region, this whole thing is 47.5, and this is 34%. The difference between these, this must be, just this section must be 13.5%. So you are going to be doing a little bit of math sense, guys, a little bit of number sense to kind of figure out, oh, should I subtract, should I add? Remember, it's all out of 100% and it's symmetrical off of the mean. The mean is always in the middle. So we're going to try one more here, and then I'm going to have you try one as a practice, and then you have a homework sheet that deals with this one problem. Okay, please take this seriously. This is a good chunk of the statistics. We're going to keep practicing. All right, let's try example 2 here. Example 2, you track the number of words in a standard text message for a month. The number of words is normally distributed with an average of 10 and a standard deviation of 1. Okay, so standard text message usually has about 10 words, and then according to whatever data they got, like a survey or something, they realized that that differs between one text each time. So we're going to do the model. So you always start with your mean in the middle, which is 10. And then one standard deviation would be, okay, so between 11 and 9, 68% of our data falls. And then between 8 and 12, 95% of our data falls. And then between 7 and 13, 99.7% of your data fall. Always have to do out to 3 standard deviations, and then we draw our little bell curve. Now, from here, we use our model and we analyze what percentages go where. So some of them are a little trickier. Again, you have to use kind of your math. So for instance, okay, less than 8. Here is 8, and that is on 1, 2, the second standard deviation. So again, though, less than 8 is outside, not within the second standard deviation. So within the second standard deviation, it's 95%. That's within. Now think, it's out of 100%. So you have to do 100 minus 95. So 100 minus 95 is 5%. Now that's not our answer because look, it's evenly split. So if this is 95% inside, the two outsides, everything below 8 and everything above 12, is evenly split up from 5%. So half of 5% is 2.5%. But versus this one where it says between 8 and 12, that's inside the second standard deviation, so that's just 95%. Okay, less than 10. 10 is the mean, which goes in the middle, so anything less than the mean or above the mean is always 50%. Between 7 and 13, sorry, 7 and 13. So that is the third standard deviation. So inside, so you don't have to do the extra math because it's already inside the full standard deviation. So third standard deviation is 99.7%. Okay, now between 10 and 13. So 10 to 13, though, is only half of the third standard deviation, guys. So the full third standard deviation takes up 99.7% of our survey, okay, or of our data. Half of that, so you just have to take your calculator and divide that by 2. 99.7 divided by 2, okay, which is 49.85%. And last but not least, greater than 13, that is the tippy top, the people that really text a lot, have a lot of text or words in text messages, like one of those people that, you know, text a paragraph and you're like, come on, really? Just give me a call. Not many of those. Greater than 13. It's the same problem as right here, guys. Every time it's bigger than the third standard deviation, it's still going to be 0.15 because the math isn't going to change from before. So, turn the page. Your goal is to be able to try one of these. Okay, so this is the first part of the homework. I want you to try one of these. Here. Just the top. Do not worry about the z-score bottom. We will be doing that in class. Pause the video here. Give yourself a couple minutes. Go in and do the problem, and then check your answers. I'm going to display the answers. So just put a pause on the video, do it, and then come back and see if you got the right answers. Okay guys, so to see if you got the right answers, we can draw our normal model. So it has a mean of 17, okay? And then from a mean of 17, here you go. Actually, I forgot I had the answer. For the mean of 17, standard deviation is 2. So we're going to go up to 19, 21, and 23. Go down to 15, 13, and 11. Clearly label the percentages, it says. So then this right here, it's a little off, I guess, with my bell, huh? One standard deviation is 68%. Two standard deviations is 95%. And three standard deviations is 99.7%. So again, my curve's a little slanted, a little skewed. All right, so let's get started here. Less than 17. 17 is the mean, so everything under that means it would be 50%. Between 13 and 21, that is 2 standard deviations, so that's 95%. Between 15 and 19, that is 1 standard deviation, so that's automatically 68%. Less than 15. 15, again, guys, is the first standard deviation. In between there is 68. 100 minus 68 is 32, divided by 2. That means it has to be 16. 16% here, 16% here. So my answer has to be 16%. Between 17 and 21. 17 again is the mean, 21 is the second standard deviation. So all I did was go, okay, between 2 standard deviations, it's 95%. Half of that is 47.5. 95 divided by 2 is 47.5%. Last but not least, greater than 23. Same thing as before. This is the third standard deviation. Anytime you could get bigger than that, has to be 0.15. It's barely there. It's that extreme, people. So you have, from here, guys, after taking these notes and trying this problem, this is your homework due for me next class. So give it a shot. It's creating a normal model, seeing how well you do. Please do not lose this packet because we will be coming back to it and we will be working on z-scores and more analyzing data.